Good afternoon, everyone, and welcome. Thank you for joining us on today's webinar. My name is Hiral Jain, and today we are presenting on the topic of shale gas as unconventional source. And to deliver webinar on this topic, we have eminent personality from the industry itself, Mr. P.K. Verma, sir. So thank you, sir, and it is very honored for us to join for you to deliver the webinar on this topic.
Thank you.
So before starting, just taking a little bit time of you to introduce our today's speaker. Mr. Verma sir has worked as a president as well as the senior vice president for exploration and production in Reliance Industries Limited. He is engineering graduate from ISM Dhanbad and has served at various levels in the ONGC. So we have, I hope that webinar will be very good for the student as well as the other student of the university which is watching that webinar. Just a little bit housekeeping before we get started. If you have any question, you can write down that question in the comment section. And now without any further ado, I will turn the time over to you, sir. Verma, sir.
Yeah, thank you. Now, today's talk is on unconventional gas, that is shale gas. And to all my dear faculty members, students, and dear friends. So, this is a great opportunity for me for sharing some details on shale gas. We shall be basically from exploration angle right up to your production, drilling, and even some innovative ideas or some important aspects of shale gas, which I will be sharing. Before that, the first slide is a safety moment. Uh, all of you must be sometime or other will be joining industry. And this industry is a very serious business. You must have heard that unfortunate accident due to weather conditions, cyclone and all in Bombay offshore ONGC, Hira field, where the Afghans barge with almost 280 people, it sank. And we are still searching for almost say uh, 70, 75 people. Out of that, we had a tally of about 29. So still something like 40, 27 or 26, and 49 is still we are searching for them. So it's a very serious business, one, and we have to be very, very careful. Safety is first. And one of the things which I have observed in my life is 6 to 9 morning, 6 to 9 evening, and shift change. They are very, very crucial because in these hours, we are slack. Uh, Either we are not agile as in the morning or tired as in the evening 6 to 9, and there are accidents across world where these times accidents have taken place. So as a safety moment, I will request that please follow this. These are golden hours for accidents. Avoid it. Okay. And as Mr. Harrell told, put your questions in chat box and sit back, relax, and learn. I have just put my email ID for anybody. If somebody needs any clarification or anything, they can contact me. Content is right from what is unconventional shale gas. There are certain details, then how to get the sweet spot, that is a part of exploration, then drilling, then hydrofracturing, production and operations, then optimization, and what are the takeaway. I'll be going a bit fast, but Certainly, I will try that you get all the basics of the content, and that way it will be easier to understand. What is it? What is unconventional shale gas? So here you can see on the base we have got the volumes. So you can see that shale gas has maximum organic value, and then we have got the methane hydrates, then coal gas, then tight gas, then conventional gas. Conventional gas is minimum on our dear earth. However, shale gas has got the least permeability. It's very, very tight. You can see that 0.0001 millidarcy is the uh, permeability of the shale gas, and which goes on increasing as we go toward the conventional, where we have got 100 millidarcy or even more than that. So you can see that unconventional gas have got less permeability and conventionals have got better permeability. Similarly, the volume increases here, but the technology and cost also increases as we go down to your shale gas, because those are very tight sands. We have to do good number of drilling wells. Then we have to go for fracturing, and go on some innovating our processes so that we are able to produce from the shale gas. And they are all very fine grained reservoir in which gas is self-sourced. It is not coming from somewhere else. It is self-sourced. And they are stored in pores and natural fractures in the form of free gas. And not all shale gas are organically rich. So we have to also find out which shale has uh, got the organically rich content. So this is just to explain the difference between a conventional and the shale gas. It's a very tight sand, very, very tight, and very, very low permeability, and difficult to produce or difficult to get. Well productivity is also low. Yeah. And gases are short hydrocarbons, CH4, methane, propane, and they have got good highest energy. And basically, these gases are pure gases, but we do get H2S also, and they need minimum refinement and minimum toxic impurities, methane and all. They are very good source for our energy. What is shale gas? There you can see here, these are the outcrops of the shale, which is a very tight. When you core it, then the core will be seen as a very tight, and you can't see gas and all in that. And when we go for microscopic one, then we see that there are certain pores. These are the pores, and in these pores, the gas is embedded. And now you can imagine that how this gas has got to come out of this shell. So these are our, you can say, uh, issues. And liberating gas requires inducing microfractures or fracking. So we have to frack it. So that's why fracking is one of the basic requirement in case of shale gas reserves. And additionally, the issue here is that the production goes down very fast. Here it is given oil, but gas also goes down very fast. You can say in say third, fourth year, uh, 3-year decline is almost 80-85%. While in normal conventional oil declines is around 5% or so. So the decline rate is here very high. That's why we have got to have a large number of wells, then we will have to go for infill wells. Some details worldwide how it is. Shale gas reserves all over the world. The maximum reserves are found in China, that is 1,275 TCF of gas. And then comes the US, it has got 860 TCF. Mexico also, it has got good gas, shale gas. Canada and even Argentina is around 770 trillion cubic feet of gas. Then South Africa also it is there, Australia also. India is comparatively prognosticated resources here in shale gas is hardly around, it varies from 60 to 90 TCF. And virtually there is no data from Russia and Middle East because most of the conventional oil and gas is there. However, in France and all, we have got some shale gas. So it is found across world, shale gas, and we are also producing. China is a good producer, US is a good producer. I'll just come to that. Now we just see USA. East USA Marcellus area is there, and that's a huge producer of shale gas. Come to your GOM, Gulf of Mexico. Haynesville is a Fayetteville is a they're also good producer of shale gas. Even in the west, we have got some fields which are having shale gas. I went here somewhere in Pioneer. Pioneer field is there, and I will just tell you something about the Pioneer field also. Okay. Now, if you see this chart at say around 2020-2021, shale gas is contributing almost 18 TCF of gas per year in USA, because these are tight gas and other gases, but shale gas, the green one, which is giving maximum of natural gas in USA as on date also. And when you see area wise, then in US, the east coast, east one, they are the Marcellus gas and other fields which I showed you. They produce almost, you can say, about say something like, if I just deduct from this 16 18, so almost you can say 50% of the gas is produced from the east coast, and balance on the Gulf and rest of the US. As you can see here, Gulf is here, and these are the others. Where we are in India, as per 2013 report, we have estimated shale gas, and the blue ones which you are seeing, that Cambay, Assam, Krishna Godavari, Kaveri basin, they are the proven one. One sec, I'll just bring it down. They are the proven ones, and the orange ones, they are the prospective for the shale gas. And they say that in place is about 583 TCF and technically recoverable. Technically recoverable shale gas is about 96 TCF. So what we have done in India? Policy announced in 2013, ONGC for 50 blocks, Oil India Limited. These are the two PSUs, ONGC and Oil India, 6 blocks. What are the activities we have done? Our activities till 1920, I mean the last year, not 2021, 1920, 4 shale wells have been drilled in 2 basins, that is by Oil India, and 29 wells have been drilled in 4 basins. Now, just give you an idea that how many wells have been drilled in USA, shale gas wells where fracking has been done. The number is mind blowing for all of us. It's about 1.7 million wells. Can you imagine? Since beginning. And we are counting in numbers, single digit or double digit numbers like 29 wells in 4 basins. So in our country, shale gas is in a very nascent stage. Okay. And other activities, some conferences have been done. Policy framework work is going on to facilitate for shale gas and oil. And then we have got to have a favorably regulatory and fiscal environment because lot of investment has to go into it. And as a matter of fact, large numbers of wells are to be drilled. Development cost is very high. I mean, environmental clearance, government clearance, land acquisition, hydrofrac. So these are the things which is a very tough job. But anyway, we have to go for it. Getting sweet spot. I'm just giving you some few slides on this. Getting sweet spot. Basically, uh, these are just a figure which is showing unconventional and conventional fossil fuel. So here it is the shale gas, which is a very gas-rich shale. So gas-rich shale is there. There are conventional oil and gas. Okay. There are oil, conventional oil and gas. These are all conventional. Pictorially, it is just shown here. And there could be some tight oil, then tight sand, gas is there. You know, we get tar sand. That's a very big, I mean, area is there for tar sand. That is in Canada. And these are, we go and drill them for this oil and gas. Okay. Now, in case of India, the first oil field was what we started producing was Digboi in Assam, where the oil and gas was, the story is that when elephants were going into the jungles to cut the trees, the oil get used to stuck on their legs, and then they came to know that there is some oil and oil is there here, and then they started drilling. Well, depths were hardly 100 feet, 200 feet to say now. I mean, then it went on becoming deeper and deeper. So low producer but very low depth. Similarly, in the west coast, in Ankleshwar, we got some water pond was there. We used to see some bubbles. Then we started drilling there, and we got Ankleshwar field. Similarly, in Jwalamukhi, ONGC went for the first time. You know the Mata there, Jwalamukhi Mata. In the cave, the priest will light a lamp, and then there will be some gas will come, and then we used to worship that. So there also we tried to get, but it was not commercial. So what I'm just trying to say that we do get some bubbles or some indication on the surface, but normally they are well buried underground, and all of you must have read this in your courses. I'm just giving you some just example. And then sweet spot identification from the seismic only. You know, in the seismic when we do, uh, then from their trends and from the results we do get some fault related fractures. Wherever faults are there, we assume there are uh, fractures are there. And when we drill it and when we find and when we go for production and tracer log, it corroborates. It says, yeah, here is the stage 7 and 8, this corner. Here is the fractures are also there as seen in our seismic surveys, and in production log and tracer log also we found high concentration for the same stages. So from seismic, then we go for pilot wells, and then we take the logs. Similarly, zone of high natural fracture density indicated by high positive curvature and image log. So positive curvature is a term used in seismic. So we do get, and natural fractures are there, and wherever natural fractures are there in our shale formation, there are chances that more gas will be there. And what we do, we take production log, and then we do the mud logs during drilling, and then we also found the highest gas count from the fractured zone while drilling. So areas with natural fracture could be considered as the sweet spot. The basic is that, and you people can go to some books on seismic and loggings, and then you can get. An easier one is what I have observed these days. Go to YouTube and get some 10 minutes, 15 minutes modules where you can get details of this. And seismic data interpretation for raw mechanical properties, the Young's modulus, Poisson's ratio, brittleness, you know, along with this lambda rho and mu rho, they are examined. Low lambda rho, high mu rho, low VPVS, they are the sign of high organic content in an unconventional cell. So from logging, we get this data. And then from your, you can say, production logging, also we will get that, we corroborate that. So from only from seismic, if you find areas of this, low lambda rho, high mu rho, low VPVS, so there we can identify that this area could be better for shale gas. Similarly, from the high frequency stratigraphy, that is your seismic, we can get the layers, and from that study we can find out the source for hydrocarbon potential. So these are basically from the seismic we do get. Okay, and then facies maps are prepared based on the seismic interpretation, and after that we go and drill the pilot holes, and then both the data, when we corroborate, then we find out which are the area best for shale gas. Now drilling, once we go for prospecting and seismic, and when we identify that these are the area, these are the depth where the shale section is there, and there if you go and drill, so we can get shale gas. For that we drill it, and initially we go for pilot hole drilling. Once we drill a pilot hole, then we go for logging, and after that, when we go for this mud logging or density log or the sonic log, then we identify the areas or the depth where, or the layer which is considered to be rich in organic matter or rich in gas. Uh, and that, those details I'm just coming to. Horizontal drilling or lateral drilling has changed the way that allow the producers to drill horizontal. And first the well is driven vertically to a depth above the target gas, Okay, and special tools are used to curve the well or to create the incline so that we can from vertical we can go to horizontal and maximum, and this is done so that we have got the maximum contact with the gas bearing zone, because as I told you that unit wise very less gas is there if we just open a few feet or few meter. However, if we increase the contact, that is the maximum contact, then we can get more gas. Then multiple horizontal wells can be drilled from one location. That is a benefit. And I'll come to that also. And compared to vertical wells, horizontal wells are more economical for shale gas extraction, as these cover large extent. Yeah, this is what it is. Say this well up to 7,500 feet, we drill with air drilling. Normally, in such areas, we go for air drilling for about 7,500 feet. Then we take deviation, and then around 5,000 to 5,500 or 6,000 feet also, we go for horizontal. So, or lateral. Lateral means we could be a little bit inclined. So almost you can say that say 7,000, 7,500 feet or 8,000 feet, we go vertical, then we go for horizontal. The wells are like normal oil and gas wells on land. That means a 38 conductor casing, then intermediate casings, then we drill, then we cement them, and this is our production casing. Here in the well, here we perforate horizontally, and these perforations could be 2,000 feet, 3,000 feet, 4,000 feet, depending on the design of the well. Okay, and this is done in stages. Say here it is written stage length is 300 feet and number of stages is 16. So 16 into 3, 1800 feet is the perforation. So it could be more also. That depends on our reservoir characteristic, the permeability or the fracturing requirement. Okay. Horizontal drilling, what the benefit is that we drill from one location. This is called drilling pad. From here I can go 1, 2, 3 wells here and 3 wells, 6 wells I can go, 4 to 6 wells I can drill. And from single drilling pad I can go for up to 400 acres. So this is advantage. And though I need more wells, but these wells can be drilled from one location. Like this is a drilling pad. And this is the rig there. And then what we are doing that from this location it can shift slightly here, get one more well, here one more well, like that. From here I can drill down and then it goes horizontally. So this is the advantage, and it cuts the cost also, because I don't have to shift the rig to 6 different locations. So that's a great advantage, and it reduces the cost also. And for drilling, we drilling from sources to pad where we are drilling, a lot of water is also required. So we go by truck or through pipeline. Then centrally location we put. Then we have got the main line, trunk line. Like this, we store at a central location here, and then we give for drilling. From drilling, we use hydrofracturing, and then we get the produced water. That produced water is again stored, then it is treated, and then again it is recycled, and part of it is you disposed of. So these are a cyclic thing, and water requirement is very, very high when we talk of hydrofracturing. This is just showing some 70-18 activities which is required in a, you can say, shale gas well or field development. You start from here, that is data gathering, source assessment, leasing, acquisition, then authorization, licenses, for permissions, then well planning design, scheduling and contracting, site preparation, then you go for drilling, complete a well, then go for hydrofracturing, then the fluids have got to be managed, then we have to manage the waste or effluent disposal, then we have to gather the gas, then establishing division of interest. Actually, in the US, all the mines are not with the government. Mines or the fields, oil field below the ground is of the landowner. So there could be one field, but could be 100 landowners. So there it's a dynamics is different. In India, it's a national asset, but in USA, it is a personal asset. Wherever you go down deep, and if you get some mineral, the landowner is the owner. Then we produce it, then we have to payment. So like this, this is a total cycle. And as a matter of fact, for any oil and gas, most of the things we do it, but for hydrofracturing, that is essential for you can say shale gas, which is not so in case of conventional oil and gas. They are also required, but that is not essential. This is just giving some timeline. 4 to 8 weeks is environmental safety seismic analysis. Drilling takes about 4 to 8 weeks. That all depends on the depth and the type. And then fracturing, maximum it takes 1 week. It's a huge fracturing. And then this in the reservoir, the sand holds the fractures open, and we produce. Then comes hydrofracturing. I think 15 more minutes or 25 minutes. How much?
Sir, 20 minutes, then we can take the question and answer.
Okay, I'll try to sum up in 20 minutes or maybe
Yes.
25 minutes. Because I have tried to cover each aspect of hydrofracturing, so such slides are more. Hydrofracturing is once you drill a well like this, and then we perforate it, and then we fracture it, and then the gas comes into the wellbore. So after drilling, the high pressure mixture of water, chemicals, sand used to blast and hold open fracture so that gas can come out. Pictorially, I'm just trying to explain you that this well horizontal section, first we have drill, then we have perforating, then we fracture it, and then gas comes. And for that we have got the surface preparation systems, and these fractures we create by uh, hydrofracturing, and hydrofracture is formed by pumping a fracturing fluid into the wellbore at increased pressure so that it fractures the surrounding rock formation. To keep the fracture open, a solid propellant is added. Solid propellant. And method of fracturing is normally called fracking or hydrofracking. In India also, we are doing a large number of hydrofracturing. We have got ONGC has got a big setup in Ahmedabad, and in all other areas also, like in Assam also, they have got the setup. And propent is commonly a sieved round sand pumped into the fracture, and many times you use ceramics so that it keeps the fracture open so that gas can come. Propent flow within the hydraulically created fractures and restrict those from closer, creating higher permeability. And that is our basic requirement. And then this hydrofracture becomes a conduit through which the gas or liquid can come back to the well. So this is just basic of hydrofracturing. As I explained you that the type of the well, so normally where I had gone in Permian Basin, the vertical depth was around 12,000 to 13,000 feet and lateral was 5,500 feet. What they do a vertical well so that they drill the pilot hole also, and then we identify which zone has got a better gas concentration through mud logging and density log and other logs. And then the horizontal section is drilled through that particular layer. And just a top of the well, that's a well bore, and we fracture like this, and the length of the fracture normally we call fracture half length, and then the fluid that comes into this fracture, and so many fractures we create in a well. So that is what it is pictorially we have represented here. And stage fracking is that that we create a cluster of 70 feet. Just example that spacing is 70 feet. Then we have perforation. So like that, this is one stage. So similarly, we can have 5 stage, 10 stage uh, fracture. And normally, what they do, they assemble the whole string in one go, and one by one, right, starting from the bottom, they go on fracturing. So that they call stage fracking or deeper fracking. I mean, these are all highly technical one, and I have seen that it's a very big job. And then we select the propent. Normally initially we pump a very small uh, sand particle or that is of 100 mesh. 100 mesh is very, very small balls, you can say. And then we go for 40, 70, 40, 80 means propents for the main area in gas shells. In some areas, we are also go for resin-coated tailings that is near the wellbore, so that while flow back resin-coated, they resist the your sand or propellant to come out of the borehole. Ceramic propellants are also used. Frac design is a very complicated one, and with the help of your computers and software, uh, we do design in a much better way. But we have got a lot of data like porosity, permeability, expected, what is the lateral length, what we are expecting to create the length, what is the type of the rock, what is the thickness, barriers, what is the depth, what are the stresses, then lithology, then is there any natural fracture or not, what type of gas or liquid is there, what is the temperature. All this data we feed into the our software hydrofrac software, and then we design this fracturing job. One second, I'll just now remove it. Okay.
Yes, sir. Yes, sir.
Then we have this various models are there, various softwares are there, and then we go for iteration of this in this model by changing various parameters like pumping rate and all, and then we optimize the design. So we have to do a lot of job in our labs, and the basic requirement is that it should go into horizontal section, not it should not just go out of the zone. If it goes out of the zone, then the fracture will not be the proper fracture. Okay, and it must be conductive propent fracture length that fits our well and perforation spacing. Many times, what happens that I'm fracturing this well, the fracture goes into the other well, which is nearby. That also we should avoid because we want to spread it in the total reservoir. That is your minimizing well interference. Okay, and it gives me the best production result. So this is a complex subject, and but we are doing it very nicely based on our experience and knowledge. You can see here one frac fleet is here. Almost 20 frac units are there. Huge job, you know. And similarly, we have got propent storages are there, frac tanks are there, hydration units are there. I visited one of those places where frac job was going on, and now you can imagine if this, and then we have got the water storage. Many places this storage is not there. The water comes through pipeline, so that also is a big job. That's why this pad is there where 5, 6 wells can be uh, drilled at from the one pad, and it reduces the cost of fracturing, cost of transportation, reduction in time, and which is essential for development of a shale gas field. Just see, this is the place where I had gone. You can see here one, two, three. These are the wells, and then how we are connecting one by one. We go on fracking, and these are all connected. Very precise job. And this is done through good fracturing fluids. Uh, the beauty is that in USA all facilities are readily available. While in India, it will need developing all equipment, facilities, and infrastructure. Type of fluid, viscosity, rheology, economics of fluid. A lot data, lab studies, and then we have to optimize this fluid selection, these parameters. They are water based, oil based, water containing sand and other propellants we have to add. Then cost effective method of increasing molecular weight, the viscosity of the fluid so that the your propellants are within the fluid. And water resources have already discussed there, the whole cycle. And typical fracking job uses 3 million gallons of fracturing fluid and about 15,000 gallons of chemical waste or flow back. So, this is also very huge requirement. Production and operation, this is regarding my visit to this pioneer field. Just give you idea, how the field looks. These are my itinerary. I was there for about one day there. I'm visiting those field. places. You can see here they are very minimum facilities. I'll come to next. And this is the office, that is area 52. It's a well organized office, and they have got a team for doing this complex drilling and high tech, high volume frac jobs. And a well organized base office is there, recreation area, gym, just flat land. There is a well behind, not too much of civil jobs. Here, this is a rig which can be towed, which can go of its own. It has got the wheels, tire wheels. It can automatically, I mean, off its own, it can go and it can lift, or it can assemble itself, so that no need of any other transportation system. Only hardened drill site area, minimum civil job. Rig is installed and jacked up, its own power system. No need for any crane. This is done all to reduce the cost of drilling, reduce the cost of jackup. Okay, top drive system for drilling, SOBM used for drilling. Bioremediation is also there. All effort to optimize and minimize costs in operating drilling, civil jobs, mobile rigs, and this is a must for your. I mean, these are just some facts that wells drill 292, well frac 280 in that area. And again, this is a vertical depth, and then it is going horizontal. Just to explain you, this is one of the well in Eagle Ford Shell. Just see, this is the diagram of the frac spread. Huge job, huge job. 20, 30 frac units are there. I showed you the zipper frac. And there in Pioneer, they are doing high volume, high pressure, multi-stage frac jobs. That means they do for each layer, they don't go separately, they complete the well, and they do this zipper method of frac treatment. Multi-stage frac job with isolation through wireline and application of CTU. And at one location, 2 to 3 wells are fracked simultaneously, as I showed you in the last picture. And all this automation is monitoring and control is done through one control van, which is located at the site itself. You know, the wells are there. They are connected to pod. Pod, they call it point of, what do you call? Point of delivery. From point of delivery, it goes to central gas plant, and then it goes to customers, to pipelines. Here it goes the rich gas, then it goes the dry gas, they go to the consumer. Beauty here is that mineral owner or landowner, and each landowner has got, or each well has got its own owner and separate line to the pod, point of delivery, and each mine owner operates separate measurement. No regular manning, only once in a day. Bare minimum facilities, all skid mounted, all skid mounted. Just see here, 2 wells here. There was a third well also nearby. Minimum of civil jobs, cellar pit at ground level. Minimum facility. Simple chemical injection portable skid run by solar pump. Once the chemical, they know that in 1 week the chemical will be finished. So the truck comes, empty one is removed, the filled one is placed here. So that way, they are minimizing the cost. Bare minimum facility. Just see here, these are all no civil work, very minimum. Fit for purpose facility. No electrical power, only pneumatic system, solar, battery. And this, just see here, this is a one gas compressor plant. bare minimum facility where they compress the gas. Facilities and operations are mostly non-populated areas. Control room is basically field panel room. There is no some big control room, fancy control room. All equipments modular. H2S is also produced. Operators have monitors on their body. Condensate is pumped up through tankers. Total area is only hardened, minimum civil job, fit for purpose facility. All skid mounted small generators. While visiting, we thought that there has got to be more interaction with Reliance people and for sharing the knowledge, sending our project and operations engineer for field visit to see their facilities, and request Director General Mine Safety to visit these facilities. Really appraise them that regulatory needs and practices in design and operation. They should not be cumbersome. There are certain hazards also with shale gas because if they're fracturing and all, they make some channel to the surface. That has got to be avoided. There are certain case study of Fayetteville shale drilling optimization. This slide I thought I'll share with you that data itself is of no use till you don't convert it into information. That information is converted into knowledge. Knowledge is then goes as an understanding and then goes the wisdom. So data gather, then report, then event recognition, then proactive operation, and then plan for optimization. So this is here in given in drilling, but I think that this is required for any area in our industry, or as a matter of fact, any industry. Data to wisdom, it must flow. Otherwise, no use of any data. Similarly, rigs are also managed, real-time technology through your data transmission, then remote monitoring, doing more with less, and data analytics playing a big role. Use of drones, optimization of services. I have got one of my friends in Slumbajar, and these drilling rigs, in his area, some 20, 30 rigs are there. And all these monitoring for safety, for operation is being done through drones, then remote monitoring. So that way, if there some of the system is not there or required from one location, he knows that this is at that location, he is immediately informed, and then it is shifted to the location where it is required. So this way they are optimizing minute to minute, and that is the role of data analytics in these days. And cost per foot has reduced, average drilling hours have reduced, average depth has reduced, average drilling days has reduced, and they have made a saving of 15 to, almost anything between 25% to 76%. Okay, and it gives benefit to the users, operational benefit, then helps in achieving consistency across the different areas, quantitative measurement, and minimum additional resource or infrastructure burden. So they have done it, they have proven it, and actually cash operating cost has reduced. Operating cost has reduced. So these are the benefits. Now, what are the takeaway from today's talk? Shale gas business is a very complex one. USA and China are leading. Our country is in very nascent stage. Subsurface complexity to be addressed in advance and in a proper manner. Large number of wells with low production and less producing life cycle. So consistently we have to go on drilling infill wells. Then high-tech systems in drilling for improving efficiency. I also explained to you the type of rigs, how they are reducing the cost, how the rig for their jackup, it doesn't require any other source, reduce the cost. And advances in hydrofracturing technology is the key so that we get the best result. Low producer standardization of technology, that is also very, very much required so that we reduce operating costs. Fit for purpose facility is essential for the economics. Technology, economics, and cost optimization is the driver. Environmental impact is to be addressed. So basically, economy, better efficiency, optimization, standardization, technology. These are some of the areas which is needed for shale gas. And thank you. I have referred DGH reports, some SP, AGP conference papers, Google, YouTube, my own visit to RIL, and company presentations also. So thank you for patient listening.
Thank you so much. Sir.
So should I stop sharing?
Yes, sir. You can stop sharing because now we have questions from the students.
Okay. Yeah, go ahead.
So we have question most of from the drilling, from the hydrofracking of the shale gas, as well as from the future aspects of the shale gas.
Okay. So tell
So
me. Yeah, one by one.
first question is from one of the viewer is that what are the future preparation to explore and produce shale gas in India?
Some glimpse I have given you in one or two slides.
Mhm.
One is that we have got huge area covering shale gas, but companies, are very few to come here. And normally this job has been given to ONGC and Oil India Limited. They are the public sector undertakings. And as I just showed you the quantum of jobs required to develop a shale gas, it's a huge investment is there. And the companies have got to be first do lot in exploration because hardly some 30 wells by ONGC and 4 wells by Oil India in last 7 years. You know that itself speaks that we are virtually nothing. While in USA the well numbers are 1.7 million wells over last 25 years.
Yes, sir.
So and they are producing something like 18 TCF of gas every year. So you can imagine, uh, and to be very frank, it can happen. This is my personal view. If a separate company in the PSU, they take up the job as a project. Like I tell you, we have got developed coal bed methane.
Yes, yes.
That was initially developed by your in Bardhaman area. That company क्या नाम है यार उसका जस्ट मैं भूल रहा हूँ and then by Reliance. But then we know that we have to have a separate team, separate group, and then right from beginning they have to talk the way. So that is one way. Another is that we have to just find out in our existing producing areas itself if there are certain shale gas layers, reserves.
Hmm.
So producing from that will be much easier because my production facility is there, all other facilities are there. So, what I can visualize that if some areas in Kalol, if I have got some shell section, so at least you go drill hydrofrac and best connecting and producing will not be a big job. And economics will also be helping because a lot of expenditure I'll be reducing. Okay, mining and everything. So that is another way. But there has to be some initiative by the companies. But it's not there as of now to that extent because the productivity is low and mindset is not going towards that.
Yes.
That is the biggest thing. Otherwise, I was there in Reliance,
Mm.
and as a project, we developed this Shadol gas field.
In Shadow, they are doing the
Yeah,
CBM also.
yeah, CBM.
Yeah.
And we are producing about 9 lakhs cubic meter per day.
Mm-hmm.
So they will be low producers from say about 100, 120 wells.
Mm-hmm.
So that is the issue because somewhere somebody has to take some bold decision
Yes.
that I want to have a separate subsidiary for
Mm.
unconventional gas in PSU like shale gas.
Yeah.
Okay, next.
So second question is related to drilling from one of our viewer, and he was asking about what type of environmental safety we have to consider while drilling of shale gas.
I tell you, these are the minimum unsafe wells
Okay.
because very low producers, not very high producers. One,
Mm.
there are not many layers like in oil and gas wells where there are so many layers and some high pressure, some low pressure, so there could be some kick. So TBM wells or shale wells, they have they are less, you can say, troublesome, more safe. I can say, put it
They
like
are
that, more
less
safe.
troublesome, more safe as compared to conventional.
Yeah.
Yeah. Okay, so third question, sir, is related to the hydrofracking, and he was asking about what are the various complications we can face during the fracking in horizontal well of shell.
I already told you that they are in world people are doing multi japper fracking. That is
Yeah,
in one
G4.
go they are fracking some 7, 8 zones of
Mm-hmm.
300 feet each. You know, so technology is developed. The biggest problem is that uh, while you are doing the job, there is some malfunction of pump.
Okay.
Okay, and we are not able to pump because
Mm.
we are designing our plan and everything, volume, and if some setback is there in some machine or something, some leak somewhere, so that creates some sort of a issues. Okay, so but basically what I say that if you take proper care, I have seen myself when I was there visiting, the whole team member before they start up the job, they will make a circle like our cricket team they do before starting the inning, and each point will be discussed and they will inform what the pumper has to do, what the other guy has to do, and they will be told that this is the way we are going to do, this is the time it will take. So everybody should be on location. They should, they should be very, very careful. And this is the expert job. It just cannot be given to anybody and everybody.
Yes.
Okay. Rest, nothing. It's like any other job.
Uh, since we have the limitation of time, sir, so we will take one or two more questions.
Okay. You
So
can send me the question on mail and
yeah,
I can reply.
you have already shared the email to the during the starting of the webinar. So all the student has noted down the email, and if they have more question, they will send you directly on the mail.
That will be good.
One of the viewer want to ask, sir, which are more preferred resource, conventional or unconventional in future?
It's all economics. If your conventional wells they dry up, and we have to go for gas, so certainly you will go for unconventional because they are poor producers and they need lot of input from the land acquisition to water requirement, you know. And even now technology is developing to reduce the water requirement of fracturing. So technology is another area.
Yeah.
And whatever we do, it should be economical. And then it will start with exploration. Drilling, we will take care. Drilling is not a big issue. You know, we are a lot of experience in conventional areas. Fracturing, high volume fracturing is a issue. I mean, experience is a issue in our country. However, that also can be taken care of.
Yes, sir.
But those logistics, land requirement, social requirement, you know, people don't allow you to work. They will not allow your vehicle to go. So those mitigations, etc., that will have to take care.
Yes. And sir, the last question, uh, he want to ask you that how we get idea from the surface that we have achieved optimum fracture length. It means desired fracture length. I mean,
From surface, we cannot know. I have mentioned in my presentation the fracture half length.
yeah.
So we design it that this is my rock property, this is my pressure, and this is my total height of the zone, and I am fracturing, giving so much of fracture. Expected fracture is say it will go up to say uh, 50 meters, suppose, and then I am expecting that my production will be say about 30,000 cubic meter per day. But when I produce, I get about only 5,000. So that is the only thing. Otherwise, you know, from the your profile of fracture and all, we can know that okay, my fracture has gone up to this length, right? Because I have programmed that, and then we have got certain logs. Through that also we can know that
Okay.
whether it has gone into the zone or it has gone up or it has gone down.
Okay, sir.
There are methods, there are technologies, and we can know that yes, all my sand or gravel has gone into the formation. If it has gone into the formation, certainly it has gone around the wellbore only. Maybe it could be that it has gone in one direction only or two direction only, not the whole 360-degree. But then we come to know. And if it goes into the another well, then we that also we come to know.
Okay, sir. Yeah, we have technology, so from the
Yeah.
technologies
That
we can.
pressure transient analysis.
Mm-hmm.
You know, we lower the manometers and then we measure the pressures difference. Then we inject, then we find out how is the response in the nearby well.
Yes.
Through that, we know that what is the connectivity.
Okay. So I urge everyone, students as well as employee, if they have more questions related to the shale gas, related to the drilling, hydrofracking of the shale gas, they can email to the sir at pkvarmaongc@gmail.com. I'm repeating again, pkvarmaongc@gmail.com. So thank you so much, sir. It was very wonderful as well as the knowledgeable session, and I'm sure that the student has get a better view of shale gas, the drilling part, the hydrofracking part, the safety part. So thank you so much, sir.
Thank you.
Thank you, sir.